Okay, so use the method of completing the square to find the standard form of a quadratic function. State the vertex and axis of symmetry of the graph of the function, and then sketch its graph. That was a mouthful. Okay, so what did you do with this particular one? Let's say you had f at x equals x squared plus 6x minus 1. Okay, with this particular problem, we want to get it in what's called standard form, which is f at x equals a times x minus h squared plus k. So that's also called vertex form, which is hk. So what we do then is complete the square on it, which if you know how to complete the square, first step is move your c across to the equal sign. So what I'll do is add 1 to both sides of the equation. And I'm going to convert this f at x to a y. So it's just a little simpler to think about. So y plus 1 equals x squared plus 6x. Then, you know, if there's a number out in front of the x squared, you have to divide by that number through everything. But luckily we don't have that in this problem. So we'll just go ahead and complete the square. So you divide your 6 by 2 and square it. So 6 divided by 2, I'll just kind of do that off to the side, is 3, and 3 squared is 9. So that's what you're going to add to both sides of the equation. So 9 here and 9 here. So once you've done that, we've got y plus 10 equals x squared plus 6x plus 9. So what that does for us then is now we can factor this, and it becomes x plus 3 equals y plus 10. And then solve for y. So y equals x plus 3 quantity squared minus 10, because you would subtract 10 from both sides of the equation once you have that. Okay. Okay, so once you have that, now you know your vertex. And so our vertex is hk, which that number right there is h, that number right there is k. Since you're pulling the 3 out of parentheses, it's going to be negative 3 for your h, and the negative 10 is not in parentheses, so that's your vertex. And that's the whole reason you complete the square, so you can find the vertex. Then your axis of symmetry is always the x value of your vertex. So axis of symmetry would be x equals negative 3. So that's going to be a vertical dotted line at that, so we can mirror. So we're ready to graph it, actually. And I'm about out of room with my paper, but I think I got enough room. So let me pull some graph paper in here, and we'll see if I got room to graph this thing. Oh yeah. Okay, so to graph that, you go negative 3, negative 10. So left 3, down 10, I think would be right there. 1, 2, 3, 4, 5, 10. Yep, and so that is your vertex. Your axis of symmetry is a dotted line through that, and I'll do it in a different color. So it's really not part of your graph. I mean, you're not plotting anything there. But there's your x equals 3. That basically anything on the left of that line can be mirrored with anything on the right of that line. And so I really only, I'm going to go ahead and find one more point for sure. This negative 1 at the beginning, if it's in the quadratic form, the negative 1 is your y-intercept. So, and you could also find that by putting a 0 in place of the x and solving it. So if you plug a 0 in there, you get negative 1. So we'll graph that. Y-intercept's negative 1. That goes right there. Because of the axis of symmetry, you can mirror that. So 3 to the right and 3 to the left gives you that. And then I don't think it asks for x-intercepts here, but I know I'm going to have them. You essentially know your graph looks like this. And the only other thing that any text or algebra class would ever ask for is your x-intercepts. And if the unfortunately, it doesn't factor. The function doesn't. If you go back to the original. So you got x squared plus 6x minus 1. And I'm going to put that up here. And so if you use quadratic formula, you'll find the x-intercepts. And it's negative 6 plus or minus the square root of 36 minus 4 times 1 times negative 1 all over 2a, which is 2. And you go ahead and simplify that. Again, on this particular problem, I don't think they asked for it, but I'm going to do it anyway. So it would be 36 plus 4, which would be 40, all over 2. So the negative 6 plus square root of 40 divided by 2, one of your answers is approximately equal to 0.16. And then the other answer, I haven't done yet, is negative 6 minus the square root of 40. Close the parentheses, divide that by 2, and you get negative 6.16. And so then you can plot those, and 0.16 is right there. Negative 6.16, it should fit right into our graph. 1, 2, 3, 4, 5, 6.16 is right there. And you have approximately where your x-intercepts are located as well. And that is everything they would ever ask you to graph on a quadratic function by hand. So, hope this helps. See you next time.